Picture this. You're an astronaut on the International Space Station, looking out at Earth, and you see something unusual alongside our moon. There's a tiny speck of light, another moon orbiting our planet, a temporary visitor from the vastness of space. And that's exactly what we're diving into today. It's not science fiction, it's happening right now. Welcome to Cosmos in a Pod, the Space and Astronomy series. Please like, comment, share, and subscribe. So we've got this asteroid 2024 PT5, about the size of a bus. It's going to be a mini moon orbiting Earth for about 56 days, starting September 2024. And get this, it was just discovered last year by the Atlas telescope in South Africa. Makes you wonder, how many other mini moons are out there just zipping around?
Well, it's actually not that uncommon for these mini moons to appear. They're just asteroids or other small objects that get temporarily captured by Earth's gravity. It's like a cosmic game of tag. Earth reels them in for a short orbital dance, then they continue their journey through the solar system.
So they're not like our permanent moon, which has been around for billions of years.
Exactly. Our moon formed with the Earth in the early solar system. But these mini moons are temporary. They get pulled into orbit around Earth for a few weeks or months before being flung back out into space by the complex interplay of gravitational forces.
Okay, so how does this cosmic capture even happen? It seems like it would take an incredible amount of precision for an asteroid to just wander into Earth's gravity.
You're absolutely right. It takes a remarkable level of precision. Think of it like trying to throw a ball into a moving basket from a really long distance. The ball needs the perfect speed and trajectory to land right in the basket. Similarly, for an asteroid to become a mini-moon, its speed and direction have to perfectly align with Earth's gravitational pull. Even a slight variation, and it would just zoom right past us.
Wow, it's like threading a cosmic needle. And all these encounters are happening all the time without most of us even knowing.
It really shows how dynamic our solar system is. It's a constant ballet of celestial objects influenced by each other's gravity, constantly shifting, interacting in fascinating ways.
I like that analogy. The cosmic ballet. So this mini-moon, 2024 PT5, we can't see it with the naked eye, right? I was hoping for a double moon night.
Unfortunately, no, you won't be able to spot it just by looking up. But astronomers will be monitoring it closely using telescopes. And for scientists, this mini-moon is a goldmine because it's a chance to study a near-Earth object up close.
Okay, so let's get into the science. Why is this little mini-moon such a big deal for scientists?
Sure.
What can we learn from it?
Well, first, it gives us a chance to refine our understanding of gravitational dynamics by observing how 2024 PT5 orbits Earth, how its path changes, and how it interacts with our planet's gravity. We can improve our models of how celestial bodies behave. It's like having a natural laboratory right in our own backyard.
So it's more than just watching a space rock go around. We're actually seeing the fundamental laws of physics in action.
Precisely. And this data can be applied in many ways. For example, it can help us better predict the trajectories of other asteroids, which is crucial for planetary defense.
Ah, planetary defense. Now we're talking. This is where it gets really interesting. Remind me, why is it so important to study these asteroids and their movements?
Well, because some asteroids could potentially threaten Earth. It's like a cosmic shooting gallery out there. While most asteroids are far away, some come uncomfortably close. By understanding how they behave in Earth's gravity, we can develop strategies to protect ourselves from impacts.
Like that meteor that exploded over Russia in 2013, the Chelyabinsk event. It caused a lot of damage. And that was from something only about twice the size of 2024 PT5.
Exactly. That event was a wake-up call. It showed how important early detection and prevention are. When it comes to asteroid threats, mini-moons like 2024 PT5 give us a chance to study these near-Earth objects in detail, and that helps us refine our planetary defense strategies.
So I'm starting to get why scientists are so excited about this mini-moon. It's not just a cool thing to see, it could help protect our planet.
Absolutely. And there's even more. Studying mini-moons can also give us clues about how other moons in our solar system formed and evolved. Did you know that Mars's two moons, Phobos and Deimos, are thought to be captured asteroids themselves?
Wow, really, Mars and moons were once asteroids, just like this one.
That's the leading theory. So by studying 2024 PT5, we might learn something about how Mars got its moons. And that could help us understand how planetary systems form and evolve over time.
That's amazing. It's like this tiny mini-moon is a window into the much larger story of our solar system's history.
Exactly. It highlights how interconnected everything is in space. Each asteroid, each comet, each mini-moon has a story to tell, a journey that led them to where they are now. And by studying them, we can piece those stories together and gain a deeper understanding of the grand cosmic dance.
I never thought of space rocks that way. They're not just inert chunks of matter floating around. They're dynamic, evolving objects that can hold incredible secrets about our solar system's past and even our planet's future. But tell me, is 2024 PT5 the first mini-moon we've ever had? Have there been others?
Oh, Earth has had quite a few mini-moon encounters. In fact, back in 2006, an asteroid called RH-120 orbited Earth for 13 months.
13 months. That's a long visit. I wonder if anyone threw it a welcome party.
Haha. And more recently, in 2020, we had a mini-moon called CD3 that stuck around for a bit. Each encounter provides valuable data, helping scientists understand how these cosmic captures occur and what we can learn from them.
So 2024 PT5 is just the latest in a long line of temporary companions for Earth.
Exactly, and it's a reminder that our planet is constantly interacting with its surroundings in ways we're only beginning to understand. There's still so much out there to discover, so many mysteries to unravel, and each mini-moon, each asteroid encounter, brings us a step closer to understanding our place in this vast and ever-evolving universe. Makes you wonder about all the possibilities out there.
It really does. We've talked about how studying mini-moons, like 2024 PT5, can help us with planetary defense and understanding how moons form. But what if we could capture an asteroid and make it our own mini-moon?
Now that's an idea. That sparked a lot of excitement and debate in the scientific community. Capturing an asteroid, bringing it into Earth's orbit. It almost sounds like science fiction,
Are
right?
you serious? We could actually wrangle an asteroid and make it orbit Earth. That sounds like something out of a movie.
I know, right? But the technology and the concepts we need to capture an asteroid, we're already developing them. Think about it. We've landed spacecraft on asteroids. We've even collected samples and brought them back to Earth.
Okay, true. We have done some incredible things in space, but capturing a whole asteroid and bringing it into orbit, that's on a whole other level. Why would we even want to do that?
The potential benefits are huge. Imagine having a space rock full of valuable resources like rare metals, water, even potential fuel sources right here, close to Earth.
So like a cosmic mining operation. No more digging deep into the Earth. We could just mine resources from space.
Exactly. It would be a complete game changer for how we get and use resources. It could help lessen the burden on Earth's resources and even give us the materials we need to build and fuel future space missions.
Wow, that's amazing. But there's got to be more to it than just mining. Right.
Of course. A captured asteroid could also be a unique platform for scientific research. Imagine a mini-moon that we control, that we can study up close, conduct experiments on, even use it as a base for further exploration of our solar system.
Like a permanent space station, but made entirely of asteroid. What kind of research could we even do there?
The possibilities are endless. We could study the asteroid's composition, learn about the early solar system. We could even conduct experiments in microgravity that we can't do here on Earth.
Okay, I can see the benefits.
Yeah.
But wouldn't capturing an asteroid be incredibly risky? What if something goes wrong and we accidentally knock it off course and send it crashing towards Earth?
That's a valid concern. Any mission to capture an asteroid would have to be planned very carefully. We'd have to choose the right asteroid, one that's not too big and has a stable orbit.
So no lassoing giant space rocks.
Definitely not. We'd be looking for something we can manage, something we can control. And the capture process itself wouldn't be about brute force. It would be about making precise maneuvers, gentle nudges, to guide the asteroid into a stable orbit around Earth. There are a few ways we could do this. Some involve using robotic spacecraft. Others use large inflatable structures to kind of envelop the asteroid and steer it.
That sounds a lot less scary than what I was picturing. More like a carefully planned ballet. Which makes sense, I guess, since we're talking about the cosmic ballet. But even if we could capture an asteroid safely, wouldn't having it orbit Earth cause some gravitational problems? What about the tides? Would it mess with the moon's orbit?
All of those are important factors that we'd need to consider very carefully. Scientists would have to run a lot of simulations and models to understand how the gravity of Earth, the moon, and the captured asteroid would all interact. The goal would be to choose an asteroid and an orbit that would minimize any disruptions. It would be a delicate balancing act, but it's definitely possible.
So there's a lot to figure out before we start bringing asteroids home with us. But it's amazing to think that this is even an option. It shows how far we've come in understanding space and developing technology.
Absolutely. Just a few decades ago, the idea of capturing an asteroid was pure science fiction. Now, it's a serious discussion in the scientific community. It shows human ingenuity and our desire to push the limits of what's possible.
It's incredible. I can't help but wonder what other seemingly impossible things we might achieve in the future. Will we have asteroid mining outposts, research stations on captured mini-moons, maybe even space tourism destinations built on comets?
The possibilities are mind-boggling, and while there are definitely challenges and risks, the potential benefits of asteroid capture are so big that it's worth exploring. It could change our relationship with space from just observing to actively interacting.
I agree. And it's not just about the science and technology. It's also about how we see ourselves in the universe. This whole conversation has got me thinking about the bigger picture. We've talked about the practical side of mini-moons and asteroid capture, but what about the philosophical implications?
No, that's an important point. It goes beyond science and technology. This is about our fundamental relationship with the cosmos. For centuries, humans have looked up at the stars with wonder, wondering about our place in the universe, trying to understand its mysteries. Now we're entering a new era, one where we might not just observe the universe, but actually shape it.
Imagine looking up at the night sky and seeing a mini-moon that we put there. It would be a powerful symbol of what we can achieve as a species, wouldn't it?
It would, and it wouldn't just be a symbol of our technology. It would also reflect how our understanding of our place in the universe is changing. For so long, we've looked up at the stars with wonder and humility, feeling small compared to the vastness of space. But now we're starting to see ourselves as something more, as active participants in the story of the universe.
From passive observers to active shapers. And it makes you question, who are we? What is our role in all of this? What kind of future do we want in space?
Exactly. It's a humbling and exciting thought. And as we think about these big questions, we need to remember our journey into space isn't just about science and technology. It's ultimately about understanding ourselves and our connection to the universe.
Like a journey of self-discovery, but on a cosmic scale.
Mm-hmm.
And as we explore further, we need to bring more than just our science and technology. We need to bring our values, our ethics, our sense of wonder.
Well said. It's a journey that needs both our minds and our hearts, and it's a journey we need to take together as a global community, sharing the responsibility and the rewards of exploring the cosmos and shaping our destiny among the stars.
It's amazing to think about. We're at a point now where these discussions about asteroid capture and the ethics of space exploration, they're not just theoretical anymore. It feels like we're on the verge of a whole new era. In our relationship with the cosmos.
It's both exciting and challenging for sure. As we gain more capabilities, our responsibilities grow too. It's like we're taking our first steps out of our cosmic cradle. We have the potential to do incredible things, but we also have to be careful with every step we take.
I love that image, humanity, taking its first steps in this vast cosmic arena. And it reminds me of something we talked about earlier, the idea of looking up and seeing a mini-moon that we put there ourselves. It would be an incredible achievement, don't you think?
Absolutely. And it wouldn't just show off our technology, it would also reflect how our understanding of our place in the universe has changed for centuries. We looked at the stars with wonder and humility. We felt small compared to the vastness of space. But now we're starting to see ourselves as more than just observers. We're becoming active participants in the story of the universe.
We're shifting from passive observers to active shapers. And it makes you think, who are we? What is our role in this grand scheme of things? What kind of future do we want to create for ourselves out there in space?
It's a truly humbling and exhilarating realization. As we ponder these profound questions, we must remember that our journey into space, it's not just about science and technology ultimately. It's about understanding ourselves and our connection with the universe.
It's like a journey of self-discovery on a cosmic scale. As we explore further, we need to bring more than just our scientific instruments and technology. We need to bring our values, our ethics, our sense of wonder.
Well said. It's a journey that requires both our minds and hearts. A journey that we need to take together as a global community, sharing the responsibility and the rewards of exploring the cosmos and shaping our destiny among the stars.
Well said. I think it's time to wrap up this incredible deep dive. But before we go, I want to leave our listeners with one final thought. The future of humanity in space. It's still being written, and we're all a part of that story. So let's embrace the wonder, the challenges, and the possibilities that lie ahead, with open minds, courageous hearts, and a deep respect for the universe we call home.
That's beautiful. And remember, the universe is vast, but our capacity for curiosity, exploration, and understanding is even greater. So keep looking up, keep asking questions, and keep dreaming big. Who knows what incredible discoveries and adventures await us in the grand cosmic tapestry.
Thank you for joining us on this cosmic adventure here at Cosmos in a Podcast. For more space exploration and discussions like this, please subscribe to our podcast and check out our YouTube channel for even more mind-blowing content. We'll see you next time, Space Explorers.